Welcome to Season 3 of Creative Solutions for a New World, Climate and Artists series. I'm Frances Littman, your host, and I'd like to gratefully acknowledge the Coast Salish people of this region and First Peoples worldwide. For thousands of years, the abundance that these lands and waters provide us to live, work, and play is due to the reciprocal relationships by which Coast Salish and the world's first people have lived and live today. Well, we have another wonderfully rich program today, thanks to Jonathan O'Riordan, who keeps the legacy of his late wife and professional cellist, Gail O'Riordan, alive through this Climate and the Arts Legacy series. Today, we have a variety of fascinating guests to share their innovative approaches to rethinking agriculture as we know it. We'll take your questions live closer to the end of this program, so feel free to use the Q&A button at the bottom of your screen if you have a question that you would like to have answered. So over to you, John. Would you like to introduce our first guest of today?
Thank you, Frances. I would indeed. So between 1961 and 2007, global agricultural production increased by 240%. Due to increased land use, increased irrigation, and fertilizers. But all of this increase came at a huge environmental cost. Today, agriculture and forestry account for 23% of all of the carbon emissions into our atmosphere. Agriculture also requires 70% of all the water we extract from our lakes, streams, and groundwater sources. And yet we waste something between 25 and 30% of all of our agricultural production each year, thus increasing greenhouse gas emissions and making water resources more scarce and more insecure. And on top of all of that, we have about 2 billion people who are overweight because they eat too much, and about 1 billion people who are undernourished because you can't have access to food. So a road to carbon neutrality requires us to turn all of these statistics on their head. Carbon neutrality means that by 2050, any residual carbon we continue to emit as humanity will have to be offset by an equivalent amount of storage of carbon by nature's systems. Increasing nature's capacity to absorb carbon is good because it increases our biodiversity. It makes systems more resilient to extreme events like floods, droughts, and fires. And it also provides spiritual and nurturing values for humanity as a whole. So today we're going to talk about water and agriculture in British Columbia. As I mentioned, agriculture consumes 70% of all water resources in BC. In a drying climate, we can expect that amount to increase, and therefore there'll be increasing competition for water and increasing insecurity for other uses. So our guest today, Ted van der Gulik, is an expert in water management in BC and has developed a wonderful model on how we can calculate water for agriculture and make the most efficient use of that important resource so we can deal and adapt to a changing climate. Ted, very nice for you to join the program and be a partner in Climate and the Arts. Very interested in what you have to say about water management in agriculture. So can you give us a little bit of background of how you developed a model that makes more efficient use for water and agriculture in British Columbia?
Hey, thanks, John. Yes, I'd like to take you through a couple of tools and models that we've developed starting back in 2006 regarding agriculture water management. And the tool that started the whole thing was the agriculture water demand model. This started in 2006. It was based on a meeting that we had in the Okanagan at the time where most people in the meeting were not really concerned about water use and water demand for domestic use because they viewed agriculture as a source of water in the future. Just take the water from agriculture, they have lots of water, we can use it in domestic. And that's when we started thinking about, we don't even know how much we need for agriculture now, and we don't know how much we need in the future, or even what our use is. How can we make decisions that water can be taken away from agriculture? So the whole genesis of the agriculture water demand model started in 2006, and then we partnered with the Summerland Research Station to develop this tool, not really knowing how we were going to do it, but I'll take you through kind of the basic structure. So it starts with a GIS lab. They take these map sheets and they go into the GIS, taking aerial photography put in all the cadaster's property boundaries, and put in the information that they can see as to crop type, irrigation system type, and such.
I noticed that you use the term GIS. Could you explain what GIS stands for and how what is its significance?
GIS stands for Graphical Information System. So you can incorporate an awful lot of information sort of layered on top of each other. So you can have soils, crop, irrigation system, climate. You can layer them all over each other. So if you're looking down on the property, all the information over that particular polygon gets collected together. The GIS system is really good at doing that. And it's very powerful, allows you to do a lot of calculations on information on a geographic basis. So once that map sheet is done, it goes to a survey crew. That survey crew visits each property. They have the GIS information in the computer. They can track exactly where they are. When they get to a property, they will pull it up on the screen and it'll tell them all the information that has already been added inside the office. And then they look at each property and then correct it, put the right crop in, right irrigation system type. If there's more than one crop, they do that. More than one irrigation system type, they draw lines on the map and bring it back to the lab and update the data. So what you end up with is a cadastre. Here on the right-hand side, you'll see an aerial photograph of what the map might show, and you can see a property there with a blue line on it. The blue lines start to tell what's happening within the cadastre property, if it's irrigated or not. We can also tell what different crops are there. And so the image on the left kind of shows you what happens. We get a different kind of a boundary for every different parcel. So if you look at the image here on the right, we have apples on part of the property. We have forage on part of the property. Part of the apples is drip irrigated. Part of it's sprinkler irrigated, so it gets separated out. Same thing with the forage and sprinklers. And this allows us to calculate the water demand for each crop irrigation system type by crop type and system type. The next thing we do, you'll see a brown line going through those properties, which is the soils information that comes in from the province. That gets added to the database. So now we know what kind of crop, what kind of irrigation system, and what kind of soil the various polygons are on. And so the soil polygons separate each property again into more polygons. And so we end up with all of that information in our database. The last thing we needed to do was get climate data, and we needed the climate data generated for the entire area. And we decided to go with a 500-meter grid of daily data. This took us quite a few years to develop, but we have now done that for the entire province, where you have daily climate data covering the province, allowing our model to pull in any year and any date from when the irrigation season starts and when it ends. The model automatically determines for the type of crop when the season starts. So in a nutshell, what the tool does, it calculates the water demand for each polygon based on crop, soil, irrigation, and climate, calculates it, adds up all the polygons within the cadastre, and then adds up all the cadastres for any watershed area, groundwater area, local government area, a region like the Okanagan. So the model can generate information for all kinds of different sizes of areas that the user may be interested in. The last part of this is that because we have different crops, of course, each crop grows differently and each crop is going to have its own demand. And so there's an algorithm in there that says once we know when the crop growing season is going to start, it calculates it on a daily basis because we apply the crop coefficient daily. And the red line here is for apples and the green line is for alfalfa. So when you go through the season, you're calculating it daily to add up the water demand for each polygon. So of course that results in a very powerful tool. And then we can start running it for a number of different regions. And we have completed the survey information for land use information in the Cowichan Valley Regional District. Here's just a bit of a summary of what you're seeing in the Cowichan Valley Regional District as to what's currently irrigated. In 1997, if you go to the far right yellow, it's 297 millimeters on average for the irrigated area. In 2003, being a hot, drier year, 1997 was a cool year, it's more than double. And the total irrigated area, both surface and groundwater in Cowichan Valley, is 2,500 hectares. And the demand shown there is 7.5 million cubic meters in 1997 and 18.5 million cubic meters in 2003.
Does your water demand model look at the future of climate and looking forward to the next several decades? Does you've got that capability to figure out what the climate might be like and what the water demand might be like by the end of the century?
The climate models are global climate models. We have 12 of them that we can run. We found out which ones are better than others, of course, but we can also average them. And the Summerland Research Station has done a lot of work to show what the increase in agriculture water demand will be based on climate. And it's showing something like a 15% increase by the 2030s, and higher, of course, by the 2050s. I should also point out, it doesn't mean that every year is going to be like that, because you could have years where you actually have a lower demand. But in general, that's the kind of projection that we're seeing.
So I should let people know that in British Columbia, agriculture uses probably about 70% of all the water extracted from streams, groundwater, and lakes around the province. So increases of 10, 15, and 20% in agricultural water demand over the next 20 to 30 years is going to be a major factor in terms of ability to secure water for agriculture and also avoid conflicts with other uses of agriculture, particularly in-stream flows, which are so critical for our fish resources, salmon and trout and steelhead in our major rivers. So one of the reasons why the water demand model is so important is that it helps to pinpoint just how much water is going to be needed now, what would be needed in the future, and how we can make the most efficient use of this large amount of water so we minimize conflicts with other potential uses. So Ted, that was a fascinating presentation of how the model is constructed, but let's see how it actually works in practice. So can you walk us through how the model operates on a farm in central Saanich, which is about 30 kilometers north of Victoria, as an example of how we calculate irrigated water demand in the province?
Yeah, so when you first go into this tool, you'll get a map of BC. I've already zoomed into it here. You can just click on the map to zoom into an area, but you can also type in your address or your PID in the top right-hand corner here, and it'll automatically bring you into this tool. I should point out that this tool has got, the basis behind this tool is it's got the 10 years of climate data from 2000 to 2010 on that 500 meter grid. I'll turn on the grid and you can see these purple lines show up. That's the grid system that goes across the entire province, of which we run our ag water demand model on, and we average the data over the 10 years from 2000 to 2010. And so that climate data is stored in a database. And when you run the model, you will be using that canned data generated by the ag water demand model.
The purple dots and green dots, what are they?
The blue dots are wells in the provincial well database, and the green dots are water licenses. If I hover over the water license here, you'll see that the license comes up and tells you what the license number is. So it tells you the amount. This is actually being used for frost protection and other stuff, but it'll tell you the use. And if you want to know more, you can click on the provincial database, click that number in, it'll tell you. Similarly with the well, let me go back to that property here. With the well, it'll also tell you the well tag number, and you can click on the well report and see what that well is used for or who owns the well. You can get all that information also.
So I'd like to let folks know that recently British Columbia brought in new laws that require major groundwater users to be licensed. They haven't been licensed at all in British Columbia for 100 years. But we've now brought in legislation that requires the major draws of water from groundwater to be licensed just like surface waters. So many of these most of these agricultural blue dots will become licensed over the next year or two. And this will add to the ability to maintain and manage how water is used in British Columbia.
So everything except domestic needs to be licensed. So that's all uses, of which agriculture probably holds most of those wells. So I've clicked on a property here that doesn't look like it's irrigated. It's 25.7 acres in size. If you know the exact, I'm going to say that, say 23 acres is actually being irrigated, or we wish to irrigate in the future. The model automatically pulls up forage, silt, loam, and sprinkler. The soil type is the actual soil type coming out of the provincial database. Forage and sprinklers are always going to be the default. So what we did is we ran the ag water demand model for forage and sprinklers all over the province to get the value of what water demand is for forage and sprinklers. And in this case, if you're growing forage with sprinklers on that soil, you're going to need 28,000 cubic meters of water over the irrigation season. You can also adjust your season a little bit if you're irrigating a little bit later, let's say middle of May to the middle of September, for example. You can go down here and that number has dropped to 24,000. So you can do it. You can get information monthly as well by clicking on this tool here. It'll give it to you by month if you want. And it also tells you the conversion factors that are used. And this is important to remember. So the conversion factor for forage and sprinklers is 1 because that's our basic demand. But if we go back up in the tool and you're not wanting to grow forage, but you want to grow, let's say you're going to grow blueberries and you're going to grow it with a drip system, the tool will then give you new factors, of course, but it's dropped the use down to 14,000 cubic meters. So this is sort of where we're at with licensing now. We can license to crop soil type irrigation system, which is a lower volume and allows us to license if that's going to be used to a lower volume to be used over time. And that kind of leads us back to what about all the licenses we have now that are based on forage and sprinkler? And so a lot of those licenses would be probably much higher than what we really need. And there's a task, I guess, if we're moving into climate change, how do we allocate water appropriately to what people actually need?
So is there a provision at all, Ted, that if someone's licensed for, say, 15,000 meters of water, and they actually only need 10,000 meters of water because they changed their crop or because they sprinkle more efficiently, they use a different technology. Is there any way in that 5,000 cubic meters can be passed on to another farmer who's desperately needing to get water so that they could start their agricultural production?
So somebody from the province would have to go out, or there has to be a request from a grower saying, hey, I need some water. This person's got a lot of water. They're over licensed. And there is an ability to transfer over from one farm to the other if the farmer with the original license is in agreement. Those kind of tools are there. They haven't been done very often. Quite often people that have water rights don't want to give them up. And so the question about if you're over licensed, what do we do? We also have a lot of farms that are under licensed. They don't have sufficient water rights. And so that's sort of the same problem. And of course, as you all know, as we get into climate change, longer growing seasons, warmer summers, hotter summers, we're going to need more water, but at the same time, our water sources will be less. Wells won't be able to supply as much in the future if groundwater dries up a bit. Certainly surface water streams will have lower flows under a climate change scenario. So this all seems to show that we're heading into and Pandora's box about how we're going to manage water in the future. And probably have to change the way we do that.
Can I ask though on that, is there provisions in provincial legislation where we can look at a watershed, look at the way in what water is going to be, water demand for agriculture is going to increase over time? And can we actually place a reserve on some water in these watersheds so that we can make sure we secure a water future for agriculture where the climate is demanding more to grow agricultural crops?
Well, that's one of the reasons why we built the tool, because we were hoping to get a water reserve regulation under the Water Act, which we now have. And so you can run this water demand model over aquifer, a watershed, a regional district, irrigation district, whatever, and you can determine what the current needs are, and you can determine what the future needs are under a climate change scenario, crop and different cropping scenarios, and increased irrigated area. And so, yes, you can reserve water for agriculture under the Act through what's called a water sustainability plan. You'd have to do a water sustainability plan that takes into account all the other uses and needs and fish flows and environmental flows, all of that, to see if there's additional water that could be reserved for agriculture. One of the things about the Water Act, you can only apply for an irrigation license if you're going to make beneficial use right away. And we have lots of ALR land that probably could use water in the future, but people are not applying for water today because they're not ready to take the water. And the intent of the water reserve is to be able to put that water aside for those growers that in the future would like to apply for a water license, whenever that may be.
So just so the viewers know, ALR stands for the Agricultural Land Reserve, and that's legislation was brought in almost 50 years ago that protects all of the agricultural land from development so that we guarantee a secure future for agriculture. I'm thinking about carbon now, Ted, and the importance of having good cover crops and moist, enough water to sustain cover crops so that soils can absorb more carbon from the atmosphere. What are your thoughts on that and how your model might be used to make that happen?
Well, obviously, if you've got a well-growing crop and it needs water and it needs irrigation, you'll be able to sink more carbon than if you have a dry crop on dry ground. And going into the future, we'll have more of those dry grounds with limited growing ability, which therefore would reduce the carbon sink. And so our model could be used for that. I guess if somebody did a study to say we increased this amount of irrigation to this area, these are the crops that we're growing, they could see what the carbon sink, how it could be increased in the future.
Ted, there's a number of people who are tuned into this webinar who would be very interested in knowing if this model can be transported to outside BC, to other parts of Canada, or even to other parts of Europe. What are your thoughts about that?
So the tool has been built for British Columbia. We have the 500-meter climate grid set here. I don't know of any other area that has that. So you would have to develop a climate grid set on a daily basis for the growing season. And you would need to get algorithms on your own type of crops that you're growing. Obviously, we've got British Columbia crops. There's no reason why it couldn't be used elsewhere if somebody put in all the time and effort to put in all the information. I think we're at about $3 million for building what we have right now.
Just to sum up here, in terms of carbon, water, and agricultural security, it's critical that this model is applied across the province. We're going to be able to use it to be very precise on how much water we use for agriculture going forward. We'll be able to forecast how the climate's changing and how that's changing the demand for water. We'll be able to hopefully bring in new irrigation technology that makes more efficient use of the water as time passes. And we're hopefully in a situation where we can continue to keep soil in good condition and moist so that it captures, the crops on it captures carbon from the atmosphere and draws down the atmospheric carbon buildup from industrial and development sources. So I think I'm summarizing to say Ted has got a fabulous tool here to make the best use of our water in British Columbia. And we hope that it can be used universally around any other parts of the world that are looking at agriculture, water demand, and carbon management and stewardship. So thanks very much, Ted, for your insights and your presentation. It was a wonderful display of what we can do in British Columbia. And we wish you the very best in continuing to develop this model in British Columbia going forward. Thanks again, Ted.
Thank you, John, and it was great to have this opportunity.
Thanks, Ted. Thanks, John. That was fascinating. In 2016, I had the great privilege of attending a program in Fairfield, Iowa at the Maharishi International University. And it was absolutely magical because that was a source of inspiration about sustainability. Our next guest, Dr. Jim Schaefer, is the founder, chairman, and president of Soil Technologies Corp., a Fairfield, Iowa-based company that develops, manufactures, and internationally distributes a family of natural technologies to serve eco-agriculture with sustainable regenerative solutions. He is one of the founding advisory board members of the Vedic Organic Agriculture Institute and a senior research scholar at Maharishi International University in Fairfield, Iowa, the first accredited university to offer a degree program in regenerative organic agriculture. Dr. Schaefer is also the president and board member of Partners for World Peace, a nonprofit corporation engaged in philanthropic work worldwide to support the improvement in the quality of life for all people on Earth. Welcome, Dr. Schaefer. I'm happy to have you here. The expression of what's old is new again applies very much to regenerative farming. Would you like to take a moment to explain what this means and how regenerative agriculture is not only a better way to capture carbon, but also a healthier option for quality of life?
This movement in the direction of being more regenerative with agriculture goes back quite a number of decades. So the origins of organic agriculture are probably 50, 60 years old now. I grew my first organic crop in 1971, 50 years ago. So I've been involved with organic agriculture for a long time. Organic agriculture, which is quite familiar to most people today, is gradually evolving into regenerative organic. So why is this better for people? There are many reasons. Why is this better for the climate? There are many reasons. For people, statistically, what we see, the number one reason people favor this type of food supply is to avoid pesticides. Okay, so for your internal life, your physiology, keeping that which is not natural, that your body doesn't really recognize out of your system, is a motivating factor for all of society, all over the world today, with respect to organic and regenerative techniques. And then for the environment, the part of our life lived outside of our body, this is equally important. And it's really the same principle, is we're trying to keep molecular structures, which are basically toxins, out of our environment so that the negative influence from those chemistries are kept at a minimum and gradually eliminated from our environment. And that's, in essence, what regenerative is about, eliminating these unwanted chemical molecules so that we're not exposed to them on a day-by-day basis. Not only for us, but for all of the animals and all of the plants. We're all working at this together. We're integrated and connected. Okay, so I will cover initially a few points about our university. And then second part of the presentation is related to sequestering of carbon and the role of soil aggregation in soil science uh, uh, connected to the process of sequestering carbon. So our Department of Agriculture and Regenerative Systems is a relatively new department for our university. And in our regenerative organic agriculture programs, we have three programs that we support. One is a certificate. It's a one-year certificate in regenerative organic agriculture. The second is a bachelor's degree in regenerative organic agriculture. And the third is a master's degree. The certificate program and the bachelor's program are conducted on campus. The master's degree is 100% online with no requirement to visit the campus. We have a farm center and a research farm and teaching farm connected to the campus. It's about 20 acres. And on this farm, the students get a chance, the undergraduate students are given an opportunity to practice agriculture. It's more like horticultural training, where they learn various methods for managing the soil, various methods for adding compost and cover crops to the soil. Here you see a machine laying down a cover crop, and then the planting is done directly into the cover crop. We do lectures around our greenhouse and farm center operations, not only for our students, but also for the general public on visiting days. Here's some of the students with one of the teachers there. The students get the undergraduate students under our bachelor's degree in regenerative organic agriculture get a lot of hands-on experience. Here they are processing compost for supporting the organic matter content of our fields. The students do all of the work on the farm. The instructors guide them. And then the students also maintain a business of selling the production, which money is used to pay some of the expenses of the farm center. So here you have a farmer's market, and the students are selling at the farmer's market. We also have a CSA, Community Supported Agricultural Program, which is subscription purchase of the organic food that's produced on our farm. So you're all welcome to learn more about what we do under the umbrella of regenerative organic agriculture, academically, intellectually. We also have a research component at our university related to regenerative organic agriculture. And we participate on a collaborative basis with other universities to conduct research to support the future of organic agriculture, to support policy related to organic agriculture. Our master's degree, we have core courses. Here you see the list of the core courses: consciousness-based agriculture, soil science, crop science, horticulture, certification, processing and handling, statistics, research method, and a research project. There are a number of electives for the students in the master's program: advanced horticulture, soil ecology, permaculture, apiculture, which is the study of bees, agroforestry, crop science, soil and water quality, biochar, medicinal plants, global organic agricultural practices, and the history of organic agriculture around the world, which takes into consideration the history of agriculture for thousands of years, and how the history of practicing agriculture, it can be integrated with modern agriculture to take advantage of what was time tested over time as methods and practices of organic agriculture. In other words, there's really nothing new under the sun. We're just rediscovering, reinventing, and applying it new. So this was a brief presentation about our university. Now I'm going to switch to a very specific topic. As a soil scientist working a lot with soil physics, I wanted to comment to you all about soil aggregation and the role of soil aggregation with respect to carbon sequestration. Soil aggregates are integral to the stabilization of organic matter in soils. The process of carbon sequestration is a linear exercise that it starts with the plant. And of course, the plant is responsible for capturing CO2 from the atmosphere. But the residues of the plant are ultimately mostly reduced to the soil. Once in the soil, this is a raw form of organic matter, but it is not really the end of the process for sequestering carbon. Organic matter with biological degradation will be reduced to humus, and then ultimately will become stabilized organic matter in the soil, or relatively stabilized. Humus is a chemistry which is composed of the most interactive part of the chemistry of humus. It was called polysaccharides. And polysaccharides are very interactive with the components of a soil. So soil aggregates are a composition of the textural elements in soils made up of clay, silt, and sand. There is a surface area to clay, silt, and sand, and this surface area has negative exchange sites. This is the electrochemistry of this mineralogy of soils, and these are called cation exchange sites. The collective measurement of the cation exchange sites is the cation exchange capacity of the soil, or the CEC. Clay has by far the greater CEC of the various textural components of a soil. Clay is largely the interactive fraction of a soil with respect to anything that's passing through the soil, whether it be water or nutrients or organic matter. The clay fraction of soil interacts with each other to form what we call aggregates. In farm management, in soil science, the management of soil aggregates is conducted in order to increase a CEC. It is the ambition in farm management and in soil management to always try to increase this cation exchange capacity of your soil. And the reasons for this is the cation exchange capacity of your soil, which is driven by a chemical reaction between clay and all of these other components like organic matter and nutrients, minerals that are used, like phosphates and potash and calcium and sulfur and iron. These are the mineral fractions that form nutrients to support the plant. The ability of the soil to hold those nutrients is driven by the CEC. Soil structure. These are the aggregates themselves, is the image of them. And we have the granular image, the blocky image, platy, massive, single images. This is the desirable one, the granular structure. It's also called a crumb structure. When soils are degraded, when they're depleted, when they've been overused, if they've been weathered extensively, then the soil profile may have and be dominated by aggregate formations that resemble more like blocky forms, platy forms, massy forms, which do not, where the surface area of the clay has been compromised. Cation exchange exists on the surface of the clay colloid. So when you are dealing with a more of a crumb type structure, the aggregate itself, the interaction between the clay particles is flocculated. And the instrument that determines the flocculation of clay to form granular crumb-like aggregates is organic matter. What you see here are images of aggregates. The area between the aggregates is small pores. The area within the aggregates, the area between the aggregates are large pores. And then you have the intermediate spaces. This is very relevant to holding of water. If you have platy aggregates, water is not held very well, especially under drought conditions, where water is held at a much higher tensile strength. So whenever you farm your fields, all soils have a proportional relationship of the different types of aggregates. Your method of farming, how you farm, the way you manage your soil has an influence on and can be measured in aggregate integrity. If the proportion of aggregates in your soil profile are very poorly structured, the agronomics of farming that field will be compromised. If you have improved the proportional aggregate structures to favor what you see here, more crumb type structures, where there's greater porosity within the pore, and the surface area of soil particulates has been enhanced and amplified and maximized. This creates a more optimum position or a better environment for supporting plant growth, where you have better air exchange between the upper atmosphere, the soil, air, and the plant. Also, and very relevant to your previous speaker, this type of soil aggregate that you see here with a much greater surface area, where the components of clay are not packed together very tightly, they've been flocculated, they're made more loose, there's more porosity here. Water gets inside these crumb type aggregates, and the aggregate functions in the soil profile a little bit like a sponge, and it holds water better. So in terms of farming practices, favoring crumb type structures is really good with respect to holding water in your soil. And it's known that if you increase the percentage of crumb-type structure in your soil, which is done by the addition of organic matter, then the demand for irrigation water decreases significantly. A properly managed soil with respect to increasing and enhancing the aggregate structures in your soil, there are measurements and published data that suggest that you can cut the demand for water by about 50%. These are micrographs, these are electron micrographs, and it shows the interaction of organic matter with clay. So you can see the organic matter has been reduced to what you would think of as like a glue or a polymer, and it sticks to the clay particles. It's relatively stable organic matter. To sequester carbon, organic matter must be reduced to this type of form, which is basically a biopolymer. And then it interacts with the clay, and you have reached the relative endpoint of sequestering carbon from the air.
Wow, thank you very much. Well, you have a website, which we can put in the chat, and we'll include information and links with the video, and we'll be back to you. Thank you so much. Your resume, by the way, is just unbelievable. We're so lucky to have you. I wanted to remind you all that if you haven't subscribed yet to Creatively United's YouTube channel, you may want to consider it and check it out. We have a food and farming video that we put together a few years ago, and you will learn about the citrus king who you're seeing here. There's someone who's growing tropical fruits right here on the west coast of Canada. There's videos that celebrate our 0 Mile Diet author and garden seed saver extraordinaire Carolyn Harriott, and urban farmer Gary McDougall, as well as all kinds of videos. So make sure you sign up for that. Now we'd like to introduce Rona McAdam, a Victoria-based poet, holistic nutritionist, and food writer. Rona has a master's in food culture and communication from the University of Gastronomic Sciences, which is the Slow Foods University in Italy. She is a longtime volunteer with the Halliburton Community Organic Farm, teaches eco-nutrition at the Canadian School of Natural Nutrition, and has been involved with the Gorge Tillicum urban farmers for many years. So since 1984, Rona has published 10 books, including 6 poetry collections, and is the author of Digging in the City, 2012, and Urban Agricultural Manifesto. Rona is working on a new poetry collection called Larder, which includes poems on bees, bugs, and food. Welcome, Rona. Before we share a short poetry video you created, might you like to provide us with a synopsis of highlights and things learned from this past week's Farm Folks, City Folk, Farmers for Climate Solutions Conference?
Yeah, it was our BC Virtual CD Saturdays, and it was a great and ambitious program of talks and various other events, including film screenings and poetry videos. And we had a wonderful keynote speech from Vandana Shiva, who, of course, inspired us all to remember to save seeds and the importance of seed security as a path to food security. And she's a dynamo. I think that talk is still up on Facebook, on Farm Folks, City Folks Facebook page. What I loved about the event was it was a virtual CD Saturdays, so you didn't have to miss out. You didn't have to, line up to see somebody you really wanted to hear and get turned away because it was sold out. So you could see everything, which meant I was glued to my screen for 2 days, but it was wonderful. I think the chief takeaway for me was just how much expertise and passion we have in our communities, and how much community support and resources are out there even during the pandemic. And particularly since so many people have taken up growing food during the pandemic. I think one thing that kept running through a lot of the sessions was the importance of biodiversity, because we know that we're losing species of insects and native plants and animals at an alarming rate. And so, whether you were talking about the importance of native seeds in your garden, or the importance of being aware of invasive species and what you're doing to native species by bringing those in, it just kept coming up. There were some great talks on how to save seeds, how to keep them viable, and just echoing what both Jim and Ted were talking about, the importance of good soil and organic matter in your soil to hold nutrients and water. So it's nice to be part of this conversation because it just keeps going round and round.
And are there videos available then on a website or something that our viewers can go back to? Are they going to be publishing anything that you're aware of?
Well, the question did actually come up, and they said they thought and discussed long and hard about this, but much like a real CD Saturday, they didn't record it. The complications of sharing videos and getting permissions and all of that were just overwhelming. So they decided, you attend it and take what you can. The as I said, Vandana Shiva's piece is on Facebook, and Farm Folk City Folk have a YouTube channel, so anything else was there. I think a couple of folks did presentations that were recorded, and of course all the poetry videos are there, which were all created just for the event.
And there was quite a number of poets at that event, was there not? You were
Yeah. They we actually had a dozen poets participate from all around BC. And for a lot of us, it was our first attempt at doing a poetry video, so it was quite an adventure. But they showed them at the start of a lot of the events, so people got a little taste of poetry before the talk.
Well, it's so nice to see this merging of climate and the arts and farming. It's all coming together. So thank you for that. And you have a poem a poem video. Are you going to show us what you had at the conference? Is that it?
Yeah.
So we're the second premiere of it, aren't we?
That's right. Before the event, we were talking about different things that we could do. They were kind of open to anything and everything. And so the word poetry got mentioned. So I kind of jumped on that and I said, let's do something with poetry. So I talked to another poet in Kelowna, Nancy Holmes, and she knows a lot of the kind of interior poets, and I know a lot of the kind of West Coast poets. So we put our heads together and she said, well, it would be more fun to do something kind of multimedia. So why not poetry videos? So we asked people to create something just for this event that had to do with gardens or seeds. And so you'll be able to see those if you go to the Farm Folk City Folk YouTube channel.
Wonderful. Thank you.
Okay.
All right. Well, and what's the name of this piece?
This is called Wild Bees. It is it's got a lot of photographs that I took in my garden and at Halliburton Farm of a lot of wild bees, not honeybees.
Wild bees. Wee multitude, sun-blossomed on leaves or dark spotting petal, pistil, stamen, knowing each flower's golden mean. Sweet comfort there for our young, priming our baskets with pollen. A day's work, and a day's work, and a day more. All this purpose. The weeds, the woods, the garden, those single destinations, never mix this with that, one source in its many places. We fly, we crawl, we gather, and again, our futures waiting to be lardered. So many homes we have, our dark places, combed and tunneled, crumbed with our comings and goings. The neatness of our labors, eggs entombed with food for an afterlife we will not witness. Our one season, this duty.
Beautiful. Thank you, Rona.
Thanks.
It's lovely. Very nice. Well, thank you so much, Rona. Thank you, Ted. Thank you, Jim. And we do have a number of questions. So I'm going to just jump right in. I'm not certain we can answer them all, John, because Ted may have to answer some of those, which we'll repost with the videos. But let's see where we can go with this. And I know Jim can probably, these will be second nature to him as well. So Jim, I hope you'll jump in on this as well. I guess a question maybe because you're in the States, Jim, but we have an agricultural land reserve here, and there is a question: how can we ensure that land is not easily taken out of the agricultural land reserve?
Well, agricultural land reserves are trusts to protect farmland, certainly in the United States as well. A lot of those are private in the US. Here we have a lot of public programs to take land out of production in order to protect from erosion and so forth. The easiest way is to compensate the private owner for protecting their land. And, you know, land, we think of it as private ownership, but it's really, it's interesting, under the laws related to land, there's no such thing as private ownership. Your rights to land are basically the right to use the land. And that's the way your legal ownership is actually defended under the law. So that doesn't mean that people who own land have the right to do whatever they want to it. Okay, so, but paying these people who have these titles to property that have surrendered their lands to trust, they need to be compensated. And as long as you put the money there, you know, I think you can convince people to do whatever. It may depend on the amount of money, but the more the better.
Thank you. Another question, Jim, that you may want to consider is what are the, can you answer what are the revenue and profits per acre from regenerative organic farming?
Well, that's a, you know, quite a complicated question, very broad question. And phasing into regenerative organic, let's say transitioning from conventional to organic, and then ultimately regenerative organic by practice and definition, the profitability of organic agriculture, as is the case with conventional agriculture, honestly, it depends on the management. So if you have good management, people learn how to practice organic agriculture well, they're not going to have any problem at all generating profits that are equal to or even superior to conventional agriculture. So, you know, if you have someone that just wants the extra price because they're growing something organic, but they don't take the time to learn about how to practice organic agriculture. Organic agriculture, and especially regenerative organic agriculture, is more management intense. And this greater management intensity is unfortunately not for everyone. Not all of our farmers are really prepared for that. They don't have the education, they don't have the orientation, they're not as intellectually oriented. But this is a growing number of people who do have these skills. And as far as worry or anxiety about the profitability in organic versus conventional, I don't have that anxiety.
Thank you. And another question here: are cisterns being encouraged to capture the extreme rainfalls in both urban and rural areas to encourage local gardens as well as commercial farming?
Well, I do know that Ted's model that he's developed for agriculture can actually also be applied to individual gardens in urban communities. So his exact model goes right down to the plot or the land title of individual properties, and you can plug in your soil type and your crop type and your cover crop, and it'll identify how much water you need each year. So if you want to practice more dry form of agriculture, you can experiment with that with his model, and you can make a huge difference in the amount of water and how much you pay in urban settings. I believe that he's now working with the CID on a model for the entire CID region. So homeowners can take advantage of it as well as agriculturalists.
Okay, we're talking about agriculture here, but should we also encourage household gardeners to use drip rather than sprinklers and hoses?
Absolutely. And as you noticed in his model, if you go from spray irrigation to a drip irrigation, you can determine immediately how much water you can save. I think on his model that he demonstrated, you could save 10,000 cubic meters a year by changing your irrigation system. So it's a huge difference.
Right. Okay. And one last question, and then we'll have to include these with our video replay. If agricultural needs will require 15% more water resources in the future, and the population of BC is going to increase, won't we run into water resource problems?
Yes, we will. And the British Columbia government has identified this because they are now looking at the whole question of water security in the future and coming up with a new strategy and a new fund to help manage conflicts in the future because of a changing climate and because of changing demands for both in-stream resources like fisheries and wildlife and for extractive agriculture. I think that the model that Ted has developed shows how the value of being very precise in terms of how much water you apply, and we can keep a track on what people are licensed for, will make the best use of our water going forward.
Excellent. Thank you. And thank you all for jumped into action. Everybody on our program who's been listening, who jumped into action to save our forests. There's another source of food that supplies life for bees and all kinds of biodiversity. So we want to thank you for helping. We're still trying to raise funds for the precious 49-acre Mountain Road forest ecosystem here in Saanich. The Habitat Acquisition Trust, with support from Creatively United, is appealing for donations to see this wildlife corridor and intact ecosystem, complete with second growth forests and a freshwater stream, talking about water, be protected from development. So animals, trees, birds, and bees, and future generations are counting on public stewardship to raise 1 million by Earth Day, April 22nd of this year, to see this area become safeguarded as a park. So please, we'll put the link in there. Please visit Mountain Road Forest to show your love, okay? And John, could you please tell us what's in store for our next webinar on Wednesday, March 10th?
Sure, we'll have a three-part webinar. We're dealing with the whole question of biodiversity and forests, because forestry in British Columbia is so ubiquitous, it covers the entire province. The first part is going to look at old growth. It's actually going to talk about a local conflict where a logging company is planning to cut down some precious old growth on Vancouver Island, and how a group of citizens, what they call the Rainforest Flying Squad, are moving around to try and prevent that cutting take place and increase the value of forests in old growth by carbon capture and show that to the courts and to the public. The second part will explicitly develop a model of how we in BC are using forestry management, both old growth and industrial forestry, but in different ways to maximize the storage of carbon in our forests rather than its release. And the final part will talk about parks and recreation and the importance of our world-class park service for biodiversity in the province and how it contributes to carbon capture. We have a proposal to protect 30% of our land base by 2030. So we'll see many ways in which this can align with our carbon strategy. It's a very exciting set of presentations. I'm looking forward to it very much.
Absolutely. And thank you, everyone. Thank you, Rhoda. Thank you, Jim. Thank you, John. Thank you, Ted, and our wonderful audience. Thank you so much. We'll see you next month. All right. Bye for now.